Hello and welcome to Textbook Engineering Problem. Today we're working out of Elementary Principles of Chemical Processes, 3rd edition, and we're doing problem number 7.3. Problem statement says, a simplified version of the life cycle of grocery sacks is shown below. So there's an acquisition, production of raw materials, and then sack production and use, and then a disposal step, okay? And then in between disposal and sack production, you can intercept some of those and recycle them, okay? So the only step that gets recycled on is the sack production and use, okay? Okay. In the late 70s, supermarkets began to replace paper sacks with polyethylene plastic sacks. In the 80s, a movement to go back to paper arose, primarily inspired by environmental considerations. In the 1990s, a counter-movement arose claiming that paper sacks have a greater negative environmental impact than plastic ones. As this book goes to press, the debate continues. Following are estimates of the atmospheric emissions and energy consumption associated with the raw materials acquisition and processing, logging, pulping, and paper making for paper, petroleum production and refining, and polymerization for polyethylene, and disposal of sacks, and for the manufacture and use of sacks. Then they give a table filled with emissions in ounces per sack and energy consumed per BTU per sack. They give it for both paper, plastic, and they give it for the two steps combined that don't include recycling, that are like without recycling. That's raw material production plus product disposal. And then sack production and use, okay? And that one gets its own because that one is within the loop of recycling, okay? All right, so it says, assume that atmospheric emissions and energy consumption do not depend on whether the new sacks are made from fresh raw materials or recycled sacks, and that it takes roughly twice as many plastic sacks as paper sacks to hold a given quantity of groceries. Okay, part A, calculate the air emissions in pounds mass and energy consumption in BTU per 100 paper sacks used and per 1,000 paper sacks used and 2,000 plastic sacks used, assuming that no sacks are recycled. Okay, so for the first part, we basically just use the table that they gave to us, right? Okay, so we say emissions for paper and for plastic. You just add both of the values that they give you for paper, for raw materials and disposal, and sack production and use, because there's no recycling. So all of it goes in for every single one of those sacks, and then we convert it into pounds mass. Okay? So 6.41 pounds mass emissions. For plastic, you do the exact same thing, but you do it with the plastic values. Okay? Except for it's 2,000 sacks instead of 1,000. Okay? 2.39 pounds mass. So a little bit less for plastic. Okay, energy consumed. Okay, so we do the same thing. Paper, plastic. You add both steps in the process, but it's in BTU per sack. 1,000 sacks, then you have this many BTUs. For plastic, you have this many BTUs per sack. 2,000 sacks, this many BTUs. Okay? Part B, estimate the number of grocery sacks used in a day in the United States. Nope, that is part C. Part B, repeat the calculations of part A, assuming that 60% of the used sacks are recycled. By what percentages are air emissions and energy consumption reduced for each sack material as a consequence of recycling? Okay, so now we're recycling sacks. We have paper. We're recycling 600, and we're getting raw materials for 400. Okay? So 400 sacks are being, this is only the This is only the raw materials production and disposal, right? And then we add 1,000. Well, you say, oh, wait, how come we're not doing 600? It's not 600, it is 1,000. How many sacks are being produced and used? 1,000, because there are 600 that are being produced and used, and there are 400 that are also being produced and used. It's just that these 400 come from a recycled stream, whereas these 600 these 600 come from the recycled stream. These are raw materials, okay? So all 1,000 will eventually get, used, and then this one is a replacement rate, okay? So 400 is your replacement rate. Okay, so anyway, you reduce it a little bit, right? Before it was 6.4, now it's 4.5, a little bit lower. You do the same thing, but you do it for, this is just for paper, this is the energy production. So 400, 1,000 for sack production and use, okay? A little bit less than what we had before. Or sorry, that was for, there we go, 1.63, 1.19, okay? A little bit less. Not that much less, a little bit less, okay. Plastic, same thing. You have 0.4 times 2,000, 2,000, 0.4 times 2,000, 2,000, okay. Multiply that by, and it's important to notice that you're adding these, right? Because these are two different steps that you're adding together. Okay. And for plastic 1.3 and 1.08, a little bit less. Okay, cool. Part C, estimate the number of grocery sacks used in a day in the United States. Population equals 300 million, and calculate the average rate of energy consumption in megawatts associated with the production, use, and disposal of these sacks, assuming that they are plastic and none are recycled. How many megawatts would be saved by 60% recycling? Okay, so first we assume that there's none recycled, which would be this scenario, and then this scenario would be if they were all recycled, or that we had 60% recycling. Okay, so you only have 40% coming from a new stream. Okay, so that's where 185 gets a little 0.4 there. Okay, so I assumed in this one that 3 sacks, sorry for the glitch, I assumed that 3 sacks per person per day, okay? So I'm assuming that, like, okay, maybe there's only one person like going grocery shopping, maybe for a household or something like that. But then you say, okay, there's a population of 300 million. So some of these people are, children or whatever, and some of them are older. And anyway, I think you could probably, if you have like 3 meals a day or something like that, maybe you have 3 sacks a day. That's kind of what I came up with. You could put your own number there. If you think it's more or less, you can change it. So estimated sacks per person per day. Okay, that's where I came up with 3. So you can see this is the population, so we're dividing by population, and then we have sacks, and then we have BTUs. So we're changing our BTUs into joules here. Okay, and then we have our days that are changing into seconds. Okay. Days into seconds. That's important because we need to change our joules per second into watts. Okay, and then we have megawatts that we're changing into. Okay, so did the same thing. I just changed X, the value of X, and it calculates to these values in megawatts. Okay. Part D, when you should have found that both atmospheric emissions and energy consumption are higher when paper is used rather than plastic, although recycling reduces the differences. Nevertheless, deciding to use plastic based entirely on this result could be a serious mistake. List several important factors that were not taken into account in making the decision, including considerations of the potential environmental impact of each type of bag. Okay, So plastic has more problems with buildup in the environment. We're pulling petroleum up out of the ground, and then we're not putting it back in the ground, right? Obviously, we're either burning it, it either ends up in the atmosphere or it ends up in our ocean or something like that. So it kind of just accumulates because nobody wants to pay to put it back under the ground, right? So that's a problem with plastic. But then the paper also chops down trees, right? So is that good or is that bad? Like trees are a source of a carbon getter, right? So we're grabbing carbon out of the air, and then it's forming the plant material. Mostly is formed from the carbon that you're pulling out of the air. So even though we're chopping down trees and then we're letting it be biodegradable or whatever, but like the trees that we're chopping down could have been, you know, producing oxygen for us and getting carbon out of the air. So, still trade-offs there as well. Neither of those things were discussed in this problem, but yeah, it's a pretty complicated problem. So, I definitely don't have the answer to that. I can tell you which one I prefer is I prefer using the plastic over the paper because the paper bags just rip and fall over all over the place, all your food. So you smash your eggs every time you use them. You could be like California and just not make bags. Everybody just brings their own bag to the supermarket, right? Just eliminate the problem. Who needs a bag when you just could bring your own bag? If you want to use a bag, just bring your own bag, right? I think that's probably a good way to do it, even if I didn't know about that law and was stranded in a supermarket holding all of my stuff because they didn't have any bags there. So they should like warn you, right? Anyway, I'm getting off the topic here. So anyway, I hope you guys have a great day. Thanks for watching. Please remember to like and subscribe and leave any comments, questions, whatever you guys have. If you have any comments on a different chapter that you would want me to do, or if you know a specific problem from the chapter you want me to look at, feel free to put it in the comments. And if I made any errors in my calculations or whatever, please put those in the comments. I'll pin those comments or that comment and put in corrections or whatever that people can look for. Anyway, thanks for watching. I hope to see you in the next one.